Today we're going to continue with section 8.2. So we're going to continue to identify characteristics of similar figures. So remember, similar means that they're the same shape, but not necessarily the same size. So here I'm giving us two triangles that are similar. Notice that I'm giving us some lengths of sides. So if we think back to the property or characteristics of similar figures, one of the characteristics is that the ratios of corresponding sides are equal. So I'm going to set up a ratio of all three sets of corresponding sides. So I'm going to start with the first triangle, and that's always going to be the numerator of my ratios. And I'm going to put that over the second triangle, which will always be the denominator. Okay, so I'm going to start with BA as one of the sides. That's going to go over then DO. That ratio of corresponding sides is going to equal the next side, which would be BT over DT. And then that's going to equal the last side, which is AT over OT. So given the information that I have, I'm going to start putting numbers in. So I know what OT is. I know that that's 15. I know what BT is. That would be 12. And I know that TD is the same thing as DT. That's 9. So notice that this first one is really of no use to us at this point. So really then what I can find first is AT, even though that's not what my final answer is going to be, because we really want to find AO or X, but I can start there. So if AT is what I'm finding, notice that 12 over 9 I could simplify. They're both divisible by 3, so that would reduce down to 4 over 3. And then I can cross multiply. So 3 times AT is going to equal 4 times 5, which is 60. I'll divide both sides by 3 and get AT to be 20. Once again, that's not my final answer, though. Notice that AT is actually an important piece of information to know, though, because it's made up of the segment AO and OT. Put those two smaller segments together and you get the segment that we just found. So I can plug 20 in for AT. I do not know what AO is, but notice that OT was given to us to be 15. And so here's our final equation. I can solve for AO by just subtracting 15 from both sides. And so it looks like our answer is 5. All right, so I'm given us that we have some similar triangles. I'm going to use the diagram to find the following. The first thing I want to find is the similarity ratio of those two triangles. So once again, the similarity ratio is going to be finding the ratio of corresponding sides and having it simplified down to its final answer. So notice that if I follow the order of the letters, it looks like if I look at the triangle of WXZ, I've got two different side lengths given. I've got ZX and WX. But if I then look at the second triangle, there's only one side of DF. So notice that DF is the first two letters. Oops. And so is WX. So those are the two sides that I want to focus on. Because I have that triangle WXZ first, that's the side that has to go on the top. So the WX of 4 is going to go on the top, which means that DF, which is 6, goes on the bottom. And then once again, I need to simplify ratios down to lowest terms. 2 over 6 is both going to be divisible by 2. So 2/3 would be that similarity ratio. All right, so now I want to find all these other things. They might be, it doesn't really matter what order I find them. Let's just kind of go with what we know. So if I want to find the measure of angle Z, I can actually find that right away. It has really nothing to do with similar triangles, and it has everything to do with the fact that 3 angles of a triangle add up to 180. And because that triangle of WZX has a 90-degree angle and a 37-degree angle, I can go ahead and I can find the measure of the angle. So I know that to find this angle, I want to do 180 minus 90 minus 37. So when I subtract those three, it looks like we get our answer to be a 53-degree angle. All right, DG. Notice that that side is going to be similar to WZ. I don't have the side for WZ. However, I can find it. Okay, notice that that's really this number 23. So let's skip and let's find WZ first. And once again, this kind of takes us back to what we talked about in the last lesson. We are dealing with right triangles. And so when you have a right triangle, we have something called the Pythagorean Theorem, where the two legs, when I square them and add them up, is going to equal the hypotenuse being squared. So a squared plus b squared equals c squared. And notice that for us, the c squared would be WZ, which is what I want. So that means that one of the sides is 4, one of the sides is 3. Once I find C, I found the side that I'm looking for. So if I square 4, I get 16. If I square 3, I get 9. When I add those together, I get 25. And to get rid of a square, I'm going to take the square root. Normally, I have two answers, both a positive and a negative. However, because we're finding the length of a side, it can only be positive. And the square root of 25 would be 5. So 5 is my answer. All right. So now if we want, because I know that that is a length of 5, we can go back to this problem number 19. We can find DG because once again, I know that my 4/6 ratio is going to then equal DG is going to be what we want to find. That has to go on the bottom because that's the second triangle. The first triangle, that side's now corresponding to 5. So here's my ratio. I can cross multiply and solve. Once again, 4/6 really reduces down to 2/3. So I think that's what I'm going to go with. When I cross multiply, I'm going to get 2 times DG to equal 3 times 5, which is 15. When I divide both sides by 2, I am going to get 15 halves or 7.5. Because it was a nice decimal, it can be a decimal. If it wasn't a nice decimal, leave it as a fraction. All right, so then we can find GF because once again, I can set that common ratio of 2/3 equal to the fact that GF has to go on the bottom because that's the second triangle. But that's going to be similar to the side that is ZX, which is 3. So then I can cross multiply. I get 2 times GF to equal 3 times 3, which is 9. So we'll divide both sides by 2, and it looks like GF. This is also going to simplify nicely. 9 divided by 2 would be 4.5. All right. The measure of angle G, we'll notice that G and Z are going to be corresponding. And when you have similar figures, corresponding angles are congruent. So since we found that measure to be 53, so is angle G. The measure of angle D then is going to be congruent to the measure of angle W. So since angle W is 37, so is angle D. And so we found every single thing that we're looking for here. All right, and then here's a multiple choice problem. It says that triangle GHI is similar to triangle JKL. Which of the following is not true? So part A, it says angle G and angle J must be right angles. Well, if I look at the picture, remember you can't assume right angles. So right now, part A is looking pretty good to us. If I look at part B, it says the measure of angle G, H, and I added together is going to equal the measure of angle J, K, and L added together, which would equal 180. And to me, that's a true statement because 3 angles of a triangle add up to 180, and G, H, and I fall in one triangle. J, K, and L fall in another, and notice how it says it equals 180. So that is a true statement, so it can't be B. If I look at letter C, if I look at these ratios, I want to make sure that these are corresponding sides. So GH or HG, notice that if I know they're similar, those are the first two letters. And notice that KJ are also the first two letters. So that first ratio makes sense. IH are the last two letters. LK are the last two letters. So that makes sense as well. So that is a true statement. They set up ratios of corresponding sides. So that is not a false statement. Notice that H and K are both in the middle of those two triangles that are named. So that means that they are congruent because remember, corresponding angles in our similar triangles are congruent. And the same thing with I and L. They're in the same spot. So that is a true statement. So that means that part A was correct to say that we can never assume right angles. It's not marked in my picture. So that is my untrue statement. Okay, so that's us identifying characteristics of similar figures.